Okay, today we're continuing in our geometry unit with lesson 8.2. We're going to be looking at angles and triangles. Okay, angles. This is all the parts of an angle. You have two rays that are sharing a common endpoint, and that endpoint is called the vertex. Types of angles. So these are going to be angles that'll we'll give you the definitions of all the different types. We know that an acute angle measures less than 90, but it's also greater than 0. And then we try to identify which ones are not acute. So looking at angle 1, I can see that it is most likely less than 90. Angle 2, however, looks like it is 90. Now typically, if it's going to be 90, it will probably have that little box in the corner so that you can tell for sure. This one didn't, but if it's on your homework and it's 90 degrees, it'll have the little box. 3 is less than 90, greater than 0. 4 is less than 90, greater than 0, but 5 is most definitely greater than 90. For right angles, they measure exactly 90 degrees. Which angle is a right angle? We already said angle 2. Obtuse are angles that measure greater than 90 but less than 180. Remember that 180 is a straight line. That is only angle 5. Again, you don't have to write all these down. A lot of this stuff is in your notes. So a line that goes infinitely in both directions and measures 180 degrees. Which is not a straight angle? Well, if you look at 1, because it has arrows on both ends, that shows that it goes infinitely in both directions. But 2 only has one arrow pointing to the right, which makes it a ray, so it is not a straight angle. The types of triangles, we are going to be classifying our triangles. Remember that triangles are a three-sided polygon. The marks show you that the sides are congruent. So in an equilateral triangle, you have 3 congruent sides, but you also have 3 congruent angles. Sometimes they call that equiangular as well. Isosceles triangle has 2 congruent equal sides. So notice that there's 1 tick mark on each of the sides that are equal to each other, and then they distinguish the third side being not equivalent or congruent with the 2 tick marks. Scalene, a scalene triangle has no congruent sides. Sometimes you'll even see it either with measures, like it'll have 3 different dimensions along the sides, or with the tick marks like this, showing you that 3 different tick marks with 3 different sides. In a right triangle, if we're going to start classifying them by their angles, a right triangle has only one right angle, 90 degrees. The box indicates that those 2 perpendicular lines are forming a 90-degree angle. An acute triangle has 3 acute angles. So if it measures 3 angles that are less than 90, but greater than, obviously, 0, then it would be called an acute triangle. And an obtuse triangle has 1 obtuse angle. We're going to try to name each type of triangle. If we look at number 1 and distinguish that all 3 sides are congruent, we could call it a equilateral. It could also be equiangular. Again, note that in this type of triangle, another way to show the angles being equal to each other is that they all have the same arc measure. So the equilateral triangle is the regular polygon for the triangle, meaning that all the angles are equal to each other and all the side lengths are equal to each other. The one that we see for triangle 2 is a right triangle because it has 1 right angle. For angle 3, we would call that isosceles. Here's another thing, even if the side lengths are not given, if you see that they have arcs or angle measures that are the same on 2 of the angles inside of a triangle, then that triangle is isosceles because the angles opposite of congruent sides are congruent to each other. So since those sides have 1 tick mark, the angles that are opposite of that 1 tick mark is going to be equal to the other angle opposite of the other tick mark. And for scalene, there's no indication whatsoever of them being equivalent for the side lengths, and they didn't give angle measures. So if we're classifying them by their sides, and I'll be specific, I'll ask you if I want the classification to be by side length or by angle measure, and sometimes by both. The interior angles of a triangle always equal 180 degrees. So all of the angles inside a triangle always add up to 180. So we're going to use this information to find a missing angle. The first question I'm going to ask you is, can the angles in a triangle have these measures? One way for us to try is we want to ask the question, does 25 plus 68 plus 87 equal 180? That's the question. So add them up. 25 plus 68 plus 87. If you add them all up, you get 180. So the answer would be yes. These could form a triangle. If you add up the three numbers and they do not equal 180, even if they equal 179.9, they do not equal 180. Let's find x given the information. So the first angle we see is 55 degrees. The box is a 90-degree angle, so this represents 90 degrees. So we know that being a triangle, 55 plus 90 plus x equal 180. You can combine the like terms right here to make things simpler. So 90 plus 55 is 145 plus x, and solve for x by subtracting 145 from both sides. So I find the value of x to be 35 degrees. You could check your work by taking 35 plus 90 plus 55 because you know they must equal 180. One more example. Find the value of x. Knowing that all measures of the inside angles have to equal 180, we have an equation that is 6x plus 4x plus 2x equal 180. The like terms are all three of these, so we would add the coefficients to get 12x equals 180. And to solve this equation, divide both sides by 12, and we'll find x is equal to 15. Now in this case, we don't give it the degree symbol because x is the variable that would have to be multiplied by 4 or by 6 or by 2 to find the actual degrees. So you don't need to put a degree symbol on that.